shift key. Okay, we call it as FSK2. So, frequency shifting is frequency modulation scheme that transmit through discrete frequency change of carrier wave. We use IC555 timer to obtain frequency shifting signal. For your information, standard digital data input frequency is 150 Hz. So, we apply this FSK in communication system, which is military communication. Second is telephone modem and caller ID.
Now we proceed with the simplest frequency shift keying, which is BFSK, binary frequency shift key. In binary frequency shift keying, they use only two digital number, which is 1 and 0. 1 is called mark frequency, while 0 is called space frequency. This 1 will increases in the graph, while 0 will be decreases in the graph. Okay, this 1 and 0 also represented by F1 and F2. F2 is 0, F1 is 1. Okay, what else? This is the graph itself. Okay, the wave have different frequency, but the amplitude and the phase will be remain constant. This is the carrier graph and this is the modulated graph. Okay, so now how to determine this 1 and 0? The value of this graph is determined by the frequency itself. This 0 will be determined by the specific frequency, and the 1 will be determined by the different frequency. Okay, I think that's all.
Okay, today I will present about the amplitude shifting. Okay, amplitude of the carrier signal is varied to create signal element. Both frequency and phase remain constant, meanwhile the amplitude will change. Normally, this is the binary for ASK. Normally, it was implemented using only two levels. It is also referred as on-off keying. The peak amplitude of one signal level is 0, and the other is the same as the amplitude of the carrier frequency. Okay. This is the diagram for the binary ASK, and this is bandwidth for the binary ASK. This is the signal element which have 5 bit rate and 5 baud rate. We have amplitude here and the time. Okay, this is the diagram for the bandwidth. FC is for the middle of the bandwidth, which is also called as the carrier frequency. The formula for the bandwidth we can use as B1 plus T multiplied by S. Here in this value we have R equal to 1 and S equal to N. Okay, the process of modulation produces a non-periodic composite signal. Bandwidth is proportional to the signal rate. Another factor is T. T is the value between the 0 and 1. This is the implementation of the BSK. This is the diagram for BSK, and this is the multiplier. If digital data are presented as digital signal, if digital data are presented as unipolar NRZ digital signal with a high voltage of 1V and low voltage with 0V, the implementation is achieved by multiplying the NRZ digital signal by the carrier signal coming from an oscillator. Okay. When the amplitude of NRZ signal is 1, the amplitude of the carrier frequency is half. Meanwhile, when the amplitude of the NRZ is 0, the amplitude of the carrier frequency is 0. Okay, we recap at what is the NRZ. Okay. NRZ is called as non-return to 0. This is one of line coding scheme which you can refer back in chapter 4. And the positive voltage defines bit 1 and the negative voltage defines bit 0. It is called NRZ because the signal does not return to 0 at the middle of the bit. Okay, let's do a question about ASK. We have an available bandwidth of 100 kHz which spans from 200 to 300 kHz. And what are the carrier frequency and the bit rate if we modulated our data by using the ASK with T1? Okay, as we know, the carrier frequency is the middle of the bandwidth. So the bandwidth is 200 to 300 kilohertz. So the bandwidth will be, the carrier frequency will be 250 kilohertz. Okay, for the bit rate, we use the formula for the bandwidth, which is 1 plus D multiplied by S. D, we got the value for D, which is 1. So 1 plus 1 is 2S. And then we use the formula for S, which is 2 minus N minus 1 over R. Okay, R, we know it. Okay, so the bandwidth, we know the value as 100 kilohertz. 100 and 2 and 1 over 1, which is equal to 1 cell. So 100 2 multiplied by x. 100 will be divided with 2 will be 50 kilohertz. So this is the bit rate for the question, and this is the carrier frequency, and this is the bit rate.
So, the next characteristic for the digital to analog modulation is PSK. So, what is PSK? So, the PSK is stand for phase shift keying. So, what is the definition? The definition is a frequency modulation scheme with which the digital information is transmitted through the discrete phase changes of a carrier wave. Next is the simplest technique for the PSK is the BPSK, which is the binary phase shifting. It uses two significant phases, which are in the graph. If it is 0 degree, so it represents 0. While if it's 180 degree, so it represents 1. In PSK, there are several constellation diagrams, which are the QPSK, the VPSK, the 8PSK, and the 16PSK. So here, I have the comparison between the PSK and the other bandpass, which is the FSK. The FSK is the frequency shifting, which we already explained before. So there are several characteristics that can be shown here, which are bandwidth, noise, power, and the error probability. From this comparison, it can be shown that the PSK has lesser compared to the FSK.
Hello everyone, my name is Aqilah. Today I will be explaining about QAM. QAM stands for Quadrative Amplitude Modulation. It is a form of modulation which is widely used for modulating data signals onto a carrier used for radio communication. It is also a combination of amplitude shift keying (ASK) and phase shift keying (PSK). Quadrative amplitude modulation is widely used because it offers advantage over other forms of data modulation. QAM is a signal in which two carriers shifted in phase by 90 degrees and are modulated, and the resultant output consists of both amplitude and phase variations. QAM restores the balance by placing two independent double sideband suppressed carrier signals in the same spectrum as one ordinary double sideband suppressed carrier signal. Later on, I will explain more detail on analog and digital QAM, digital quantized QAM basics, the advantages and disadvantages, and the QAM versus other modulation formats. Analog QAM is used to allow multiple analog signals to be carried on a single carrier. It is also used in PAL and NTSC television systems, where the different channels provided by QAM enable it to carry the components of chroma or color info. System is known as CQAM that are used for AM stereo radio. Here, the different channels enable the two channels required for stereo to be carried on the single carrier. Now we move on to digital or quantized QAM. In the digital QAM, it is increasingly used for data communication system nowadays. They are able to carry higher data rates than ordinary amplitude modulated schemes and phase modulated schemes. The constellation points are normally arranged in a square grid with equal vertical and horizontal spacing, as we can see in the drawing below. As a result, the most common forms of QAM use a constellation with the number of points equal to a power of 2. For example, 4, 16, and 64.
Now, I will explain the advantages and disadvantages of quadratic amplitude modulation. The advantage of QAM is it increases the efficiency of transmission, while the disadvantages are it is more susceptible to noise because the states are closer together, so that a lower level of noise is needed to move the signal to a different decision point. For now, I will explain on the QAM versus other modulation formats. As we can see here, the types of modulation is OOK, BPSK, QPSK, 16 QAM and 64 QAM. And when we see the complexity here, the ones that are QAM have higher complexity than the others modulate. And when we see the error margin, the one that are QAM has lower error than the ones that are OOK, BPSK and QPSK. Hence, it is better to use QAM as a modulator.